Hello everyone, today we're talking about functions of angles, section 6.3 in our book. So they want us to find the exact value of the trig functions. So here they've given us cotangent of negative pi over 4. So the first thing I'm going to do is I like to draw the angle. So negative pi over 4 means I start going counterclockwise, and pi over 4 is 45 degrees. So negative pi over 4 gets me to this angle here. So next, I can use the fact that I know that cotangent of negative pi over 4 is equal to 1 over the tangent of negative pi over 4. And I'm going to real quickly solve for tangent of negative pi over 4, and then I can plug it back in. I know that the tangent is equal to the sine of negative pi over 4 divided by the cosine of negative pi over 4, which gets me to the sine value is going to be negative because I'm in the fourth quadrant, so negative radical 2 over 2. The cosine value is going to be positive because x values are positive in the fourth quadrant, so radical 2 over 2. And when I flip and multiply, I get negative 1. So the tangent of negative pi over 4 is negative 1. So if I go ahead and plug that into my cotangent equation, I get 1 over negative 1, which is just negative 1, giving me the exact value for cotangent of negative pi over 4. So very similar to what we've been doing in chapter 5, maybe just different angles than we're used to now, using negative angles instead of typically positive angles. Also want to make a note, when they say exact value, you cannot just type this into your calculator. A lot of you did that even for the chapter 7. So you have to type it, you have to actually go ahead and solve and find an exact value, whether that be a radical, or in this case it turns out to be a nice neat whole number, negative 1. So now find the values of the trig functions from the given information. Okay, so I know cosecant is equal to 2. And I know theta is in the first quadrant. So I know, I'm going to draw my triangle. I know that I'm in the first quadrant. So I know my theta is in the first quadrant. And cosecant is equal to 1 over the sine of theta. So if cosecant equals 2, I can go ahead and switch my 2 and my sine, and I get sine theta equals 1/2. So if sine theta equals 1/2, that means my opposite is 1, my hypotenuse is 2, and if you go ahead and do the Pythagorean theorem, we get radical 3 over 2 for my missing side. So now that I know all three sides, I can go ahead and I already have cosecant is 2. I found the sine to be 1/2. So then I'll just go ahead and find the cosine. Cosine is adjacent over hypotenuse. So that's radical 3 over 2 divided by radical 3 over 2. I'm sorry, it's just radical 3 here. So radical 3 over 2. So if I do my Pythagorean theorem, I get radical 3 from missing side, not radical 3 over 2. And then my cosine is going to be radical 3 over 2. Then I come to tangent. That's sine divided by cosine, so that's 1/2 divided by radical 3 over 2, which just gives me 1 over radical 3, which simplifies to radical 3 over 3. And then I'm still missing secant and cotangent. So secant theta is just the cosine reversed. So this equals 2 radical 3 over 3. And then the cotangent of theta is just the tangent reversed. So this one was 1 over radical 3, so I get radical 3. So there we found all 6 trig functions. The 5 other trig functions, given the first trig function and what quadrant it's in. So this one happened to be in quadrant 1, so all these values are positive. If it were in a different quadrant, you'd have to take into account whether my values would be positive or negative for my x and y. And finally, find the area of an equilateral triangle with a side length of 10. So here we have our area formula, and this is the area formula we're going to use if we do not have a right triangle. Right? So we know the typical area formula, 1/2 base times height. But if we don't have a right angle, it's hard to determine the height. So here we don't need the height, we just need to know 2 side lengths and then the angle in between them. So I'm going to go ahead and draw my triangle. Okay, I'll label it with A, B, and C. Those are my angles, A, B, and C. They tell me it's an equilateral triangle, so I know they're all 60 degrees. And they say it's an equilateral triangle with length 10, so I know that my sides are length 10. So, a key thing to note in the area formula is this little a here means side. That little a means side A, the side across from angle A. Just like the little b here means side B, the side across from angle B. And same thing here. If I had a different angle, right here they have us using side or angle C, then that would be side C. So I'm going to go ahead and plug it into my area formula. My A is my side opposite A, so 10. My B is my side opposite B, so 10. And the reason why I know that this lowercase a and lowercase b are sides is they're going to write the sides lowercase. So we see that the a and b are lowercase, and the angles are going to be capitalized. So this is a capital C, lowercase a and b, so I know those are sides. And then, so here I have side A, side B, so the angle in between, maybe if I even wrote, so here I have side B, I have side A, so the angle in between them is 60 degrees, so I have to do sine of 60 degrees. So now I go ahead and compute that in my calculator, making sure that my calculator is in degree mode. And if I go ahead and plug that in, I get 43.30 back. So go ahead and try the 3 example problems that accompany this in the PowerPoint. The answers are again at the end of the PowerPoint, so you can check your answers, and we'll go over this in class tomorrow.